All right, so this, let me turn this microphone. So this will be, we're discussing the 2 labs that are outstanding that we need to do to get done. The friction lab, I'm going to say, is going to be due by Monday. That's really simple. We'll go over exactly what I'm asking for real quickly. And then the egg lab, which I will spend a little bit more time talking about what I'm expecting, will be due on Tuesday. All right. Because that's next week. Okay. All right. For the friction lab, what am I expecting? That's due Monday. Abstract, what did you do? I'm trying to find the coefficient of friction by tilting this board, okay, and waiting for the friction. What do I want in the quantitative part? I want to know show me your calculation from you. You should have used, like, henceforth and forever, if you ever have to process more than 1 data point, I want Excel. So for this, you should have used Excel to calculate and average all of the mu's for your group. Okay? And you're going to need to do something called percent error. Percent error is observation minus actual over the actual value. In your case, your observation is your mu, your average mu. Okay? And the actual value is the class average for mu, which I'm going to give you in just a minute. Okay? I multiply that by 100%. And then also you're going to discuss your uncertainty. Now, clearly, in this lab, your uncertainty of your measurements would be very small, right? Because you're just measuring how long the incline is, which you know exactly, and how highly you elevated one end of it, which is very, that's completely unambiguous, right? So you're looking at millimeters of uncertainty. But if you look at all of your values for mu, were they all identical? I don't think anybody got 5 identical values, did you? Yeah, like no one. Even though you're doing the same thing, lift it back up to the same point. You didn't get. So there must be some other source. What is the source of uncertainty in this friction lab? So is this bar, is it raising this to a certain height? Was that what was causing you uncertainty? Like, what was the thing that kept changing? Yeah, like the level that you raised it to before it slid. Did you notice weird things? Like if you pushed on it when it was flat and then raised it up, it went higher. If you took it off and then gently set it down as you raised it up, then it would slide at a lower level. So the issue, the uncertain part here, is the actual force of friction, right? How you contact those 2 surfaces changed mu. That's why you got different levels. So, how do you calculate uncertainty? The easy way to do that is to look experimentally, right? Look at, let's say, for example, the height that you raised your the thing to, right? Like you measured that vertical height, and then you could look at the average for your whole group, and then take the standard deviation of that average, and it'll be plus or minus the standard deviation. So your uncertainty will just be the plus or minus the standard deviation, right? So it's not that crazy. You don't have to do that big square root formula and all that kind of stuff, right? Because the length never changes. That doesn't affect anything. The thing that gets affected is its up and downness. But the measurement, do you get what I'm saying here? The measurement of the height is not your uncertainty. The uncertainty was caused by the interaction between the board, the block, and the board. And so the only way you can really get a grip on that is experimentally. So you look at that experimentally, and you'll see the effect. So once again, for your uncertainty, you can just look at, I guess, technically, since they're all just simple functions of that, you could take your mu, look at your average, take the standard deviation of your mu's, and then that should give you your uncertainty. Because then you can say plus or minus whatever amount. Does that make sense, what I'm just saying? Okay, good. Just take the standard deviation, use that or plus or minus, and then that should give you a nice little buffer zone there. Now, remember, your qualitative analysis always has to use the information from your quantitative. It's like when you do, you remember in AP when you did I don't know what they call them now. They used to call them DBQs, document-based questions, and they still do those? Okay. You remember, like, one of the holy rules, the laws of the land of doing a DBQ was you had to specifically use information from the DBQ. Like, you couldn't write some general statement. I don't know if Ms. Lyon said that to you guys, but my history teacher, Mirth, that was her name, Mirth Buckley. Anyways, she was emphatic about you have to pick at least 2 or 3 things out of every document that you're writing about to give an answer. That's like this. Your qualitative analysis is useless if you do not discuss your quantitative values. Okay, questions? Anybody unclear on what I'm asking for? And obviously, this just goes on top of your other stuff, right? Your log should be on the back of this. And then you should have used Excel probably to calculate all your values. Okay? If you have to calculate something more than, like, say, 3 or 4 times, you have to use Excel. I do not want you, like, using your calculator 5 times, plugging it in. You should be using Excel so you learn how to use it. Questions?
So should we go back and plug everything into Excel?
Yeah, that would be good. Okay, so that's it. That's due Monday. Percent error, uncertainty, and mu. Okay. Next, on Tuesday, the Egg Lab. Once again, we're just talking about the top page with your abstract, quantitative, and qualitative. Okay. The abstract's pretty simple. You're supposed to design something to catch an egg, right, etc. What is it that you are calculating quantitatively? There are 2 things that I want calculated. Number 1, how much force did you exert on your egg? And number 2, what was the velocity of your egg when it hit your catcher? Okay, the velocity one should be trivial. What was the initial velocity of your egg? 0. What was the distance your egg fell? 1 meter. What was the acceleration of your egg? 9.8, yes? So everybody's egg should be about the same velocity. It might depend. If you had a catcher that was very tall and the egg didn't hit until a higher spot, somebody might be off like 3 or 4 centimeters, something like that. It's not going to be 3 or 4 or 5% at most. So that's easy. Make sure you put that there. Let's see. Yeah, and you know what? Let's make sure we talk about uncertainties for those calculations as well. I want to know how confident are you of your calculations for those things, for both of them. So in terms of, you have one drop, so you can't use your data to come up with uncertainty. You'll have to look at your actual measuring devices in order to come up with that. So for your velocity, you actually might be pretty close. You might be pretty confident in that. With your force, now this is where it's going to be a little bit more interesting, right? You're going to have to consider how do you calculate the force, and then what goes into that calculation, and then how certain are you there of those things, and I'll talk about more of that in just a second. If your egg did not crack, okay, what you are doing is calculating your force. That's pretty much it. Your force with your velocity and your uncertainties, and then a little bit of qualitative in terms of what do you think was good about it? How would you, could you improve it? That sort of thing. You just a couple of sentences, nice and easy. You did the hard part already. You caught the egg. So you're going to get a 10, okay, as long as you do this. However, if your egg cracked, okay, in order to get the 9, which is still an 8, so you'll get an 8 on the left. In order to get the 9, you must use frame captures. So you have to go through the video, which I'll show you, and it's already on YouTube at, go to GHS McClure at YouTube, and then look at there, and you'll see all your videos are already online. If you have trouble with those videos, I have all of them on my computer. I haven't thrown them away yet. So if you need it, come to me and I'll give you a, and I'm also posting this video on that channel as well. So both things should be there. At least I hope this video works. You need to do frame captures from the video of your egg falling. And in your frame captures, you want to capture the moments where your catcher failed. So you want to say, right here. See the egg bouncing out? That's the problem. Right? We were good until it bounced out of the catcher and landed on the ground. Or we were good until the thing fell over and then cracked on its side. So on that frame, I want you to be like drawing, writing, indicating, or if you don't know how to draw on a picture, at least underneath it, you're writing and telling me, okay, if I had done this and this and this, then this could not have happened. If I had made the base wider and by this much, then that wouldn't have happened. It wouldn't have fallen over. This would have happened. If I had added enough of this, if I put more tape across the bottom, then the egg would have just went straight through and exploded. And that sort of stuff. Actually, I don't think anybody's did that in here, did they? Yeah, that was third period. That was awesome. Pop! It's just like right on the bottom. Although, yeah. Yesterday, somebody came in for the 2-meter drop. That was pretty cool. And like their egg fell and turned kind of sideways, and they had like one of those inverted, like the volcano cup things. And I did not even think this was possible, but the edge of the paper cut the egg in half. Yeah, like it just sort of whack, and then the top fell off, and yeah, it was amazing. I'm not even kidding. Those people who were here yesterday, yeah, right? It's like it just sheared off the top of the egg. All the egg contents just went bloop on the ground. And then the egg was this nice little cut open thing. That was cool.
It wasn't quite straight, was it?
It wasn't a perfect shear, but it was surprisingly precise. I was like, wow, that's amazing. Okay, well anyways, obviously did somebody from here get the 2 meters? Katie got it. Katie's group.
Gracie.
Oh, Gracie. Wow. Whoops. Katie's
Third period.
third period. Sorry, Gracie. I apologize. I think she might even sing the same scene. Because that's Katie's third period. Yeah. Anyways, I'm sorry, Gracie. Gracie got it yesterday. Her group. So that was literally only Gracie got it because only Gracie was here. Her group members can talk to me later if they want extra credit because you should have been here to support. Anyways, yeah. So. If your egg broke, I want to see frame captures, I want to see explanations. And understand, if you kind of half speed this thing, you will get a 7. You must prove to me that what you are suggesting to change will actually save your egg. You have to show me that logically the changes you're going to make are going to result in a successful drop. Right? If I don't feel like that when I'm done reading it, you're not going to get 9. If I feel, it's like 7, 8. You won't be lower than a 7. So that's, you actually built something, you went through the stress of pulling the pin and watching it fall and, whatever.
Agony of seeing it crack.
Yeah, the agony of seeing it. What's worse, third period, somebody's went foop, and it looked like it was fine. And they were all excited, they're like cheering, and then they opened it up, pulled it up, and it's like a hairline crack. You couldn't even see the crack without the flashlight, and they're like, dire. Okay, is everybody clear on what I'm looking for here? Questions? Okay, so now let's talk real quickly about how you calculate these things. I think I will show one of yours, period 4. Let's go here.
Hey there.
Hey. Thank you, sir.
You're welcome.
Okay. Yeah. That's a problem with Ian. Always so much drama. No, just kidding. He was hoping I wouldn't. Okay. So if we run through this video and then pause it, you can go through and actually go frame by frame. This video was captured at 1200 frames per second. So each frame is how much time? 1/1200th of a second. Okay. Okay, so we can see this egg going here. So you can actually, knowing the dimensions of your catcher, that's why I said you have to actually have exactly the dimensions of your catcher. So that you can say, wait, I know my catcher was, this point to this point was 7 centimeters. So if you know that, then on the screen, on your paper, when you print it out, you can say, okay, 2 centimeters on my paper is 7 centimeters in real life. So then, if I count how many frames the egg moves, like let's say you do 10, right? So you go like, oops. So let's say you go like, you put a line, and then you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you draw another line. You measure that in centimeters. Use your conversion factor, and that gives you the literal distance the egg traveled in, if it's 10 frames, that's 1/120th of a second. So now I know literally the velocity of my egg at that point. Now the other way that you can know is the end of that ruler is at 1 meter. Right? So when the egg reaches there, whatever, the end of the ruler, ding, that egg, you should know exactly how fast that's moving because of your calculations, right? V squared is equal to V0 squared plus 2ax. Therefore, V is equal to the square root of 2ax. Pretty straightforward there. Now, so that's the velocity. If we keep going, you should be able to see when the egg starts touching the catcher. There. Oh, maybe there. It's like a speaker. Anyways, right, you can see, yeah, I think it's right there. So, you know then, and then if you walk through this, when did the egg stop? So if the catcher's moving upwards, the egg must have stopped already. Does that make sense? Because the catcher can't move up if the egg's still moving down. So if I go back and then, boom, I'm thinking right about there. So I can count the number of frames between when I first saw the contact to the moment where I think, and I'm guessing, where the egg stops. And then because I know the time, I can calculate the acceleration. And if I know the acceleration, and I know the mass of the egg, I can calculate the force, right? And so you can figure out the force that your egg catcher exerted on your egg. Obviously, that only works for people who successfully caught their egg, and the people whose egg broke because it fell sideways or bounced out. Because even if your egg bounced out, or if your catcher fell sideways, you still stopped the egg successfully. Sadly, you just didn't take care of it. Does that kind of make sense? Yeah. So I want a velocity calculation for everyone who stopped their egg in their catcher. Right? So even if the egg came out and broke or fell and broke, you have to still do it. All right. Any questions on how to find the force? Any questions on how to find the velocity?
Can you say the force thing again?
Sure. Basically, find out how many frames between the moment it touches your catcher to the moment the egg stops going downward. And then that's going to give you a certain amount of time. Then if I know the time it took to stop, the final velocity is 0. I know roughly, I know the initial velocity because I calculated it already. Now I can find the acceleration. Because v is equal to v0 plus at. So a is equal to v minus v0 over t. Okay, a should be the change in velocity over time. And then, of course, once I know the acceleration, because of Newton's second law, I know the mass. Well, because of a balance, I know the mass. And I told you 65 grams, whatever. And I mean, that will be part of your uncertainty too, right? Because you're going to be like, okay, I don't know if that egg was actually 65 grams. It could have been, you know, so you're going to say, okay, there's a little bit of fudge there. But because you're using that mass, you have acceleration, you can tell me the force. And then you'll come up with an uncertainty of that force based on the roundings that you did. Okay, other questions? Okay, so if we go back to this, okay, so if we go here and we say, okay, the force that it stopped is going to equal to the mass times the this minus v0 over t, right? Look at what measurements you took. We know that this v is supposed to be 0, right? This v0 is from your v is equal to the square root of 2ax, right? With this being 1 meter, this being 9.8 meters per second squared. Everybody cool this? So that gives me that. So then the question, let's look at sources of uncertainty. This, did it travel exactly 1 meter? See, probably not, because you probably went in. Now, if you use the video to watch and see how far it travels or how long it travels before it even contacts the catcher, then you can come up with a pretty good idea of how fast it was going, or how far it traveled, either one. So that's a way you can check that. And of course, that's for this. And then the time is a source, but that's pretty accurate, right? These are very, very tiny time increments. And then the mass is a source. So those are like your 3 areas of error. This uncertainty, the way this will come into play is not, like you're not going to say, okay, my uncertainty is 1/1200th of a second over whatever. Your uncertainty is, do you know when it stopped? Because it's inside your catcher, right? So when you do it, what you want to do is like on that one where we saw it bounce up, that's pretty cool because you have a very good idea when that egg stopped. But if your catcher completely just surrounds it and you have no idea, then what you have to do is say, okay, well, I'm not sure now. How sure am I? Am I sure within 1 frame? Am I sure within 5 frames? Am I sure within 10 frames? And then that will give you the uncertainty of your time, right? So if you're like, okay, I know it stopped sometime within these 10 frames, then and you're saying like the time it took to stop is this. Do you remember the uncertainty calculations we did before? Where we did like, okay, I'm writing with a white highlighter. The uncertainty was, this was like your, kind of like your increment over your measurement, right? This increment, this is kind of like your confidence number, right? Like, so let's say you think on here that it took 6 frames for your egg to stop, but I'm not sure. I know it's somewhere between, it's got to be more than 3, but it's got to be less than 10, right? So then you're like, okay, so it's somewhere, like if you think this is 6, like 6 frames, the increment is like plus or minus 3. Do you see that? What I'm saying there? So the increment is like plus 3. And so then that gives you your uncertainty. And then that all of these kind of fit together. Right, just whatever to sort of be clear. This one, I think you can take care of this uncertainty by using the video to know exactly how far it fell, because you'll be able to see what part of your catcher it traveled to before it hit the egg. So that one can be taken care of that. So in terms of this, there's really only these two, and this uncertainty is a guess by you. In a package of eggs, we said 65, the average value is 65. What do you think? Is it plus or minus 15 grams? Is it plus or minus 5 grams? Say how you think, that's fine. If you want to come and measure a bunch of eggs after school and get a very, very good uncertainty, that's fine too. Okay. And then, of course, once you have your total uncertainty, will be the square root of the squares of these two. So that's for the time, and that one's for the mass. Like I said, this one right here, just use the video to get a value there, just because it's squared, and I don't want you to have to mess with it. Okay? Questions? All right, so that's Tuesday. I strongly encourage you to try to do some of this before Tuesday or before Monday night. Right, try to do it over the weekend. Feel free to ask around or message me if you have a question, etc., etc. All right. Okay, and that is the video.